Hello, this is Ms. DB. In this video we're going to talk about scale and scale factor. So we'll be looking at special ratios between units of measurement. So there's lots of times where we use ratios and proportions, and one of those times is maps or scale drawings or models of real life things. So for example, let's talk about a map. We can't draw 500 miles on a map. You can't make a map that's 500 miles long because it wouldn't fit in your pocket or your car. So instead we use a scale to help us represent 500 miles. Similarly, we can't draw a building 20 stories high, but we can use a scale to help us draw it that it fits on a piece of paper. We can't build a life-size model of a home or a car, so we use a scale to help us. So ratios is the key. That's what we're going to use. So for a map, that's an example of a scale drawing. And there's lots of other scale drawings. Let's look down here for a minute. Here's an example of a map. This one's zoomed out a little bit. So they have a scale on the side in a couple different ways that tells us how to find the distance between things. The first one says that 1 inch equals 250 miles. The second one says 1 centimeter equals 160 kilometers. So you can measure with either inches or centimeters and find how far apart two things would be. And then there's also down here you can see that there's another way of representing scale with this picture here. And we can use that too. Here's one that's more zoomed in on a map. So this time 1 inch equals 20 miles. So you can take one measure between two things, and if it's about an inch, then you know it's 20 miles. Over here's an example of a scale drawing. So unlike a map, we have a horse. So we don't want to draw the whole horse, so we do a picture, and it says that the scale is 1 to 10. So the drawn horse is 150 millimeters. The real horse would be 10 times that, so 1,500 millimeters, and so on. So those are two examples of when you would use scale to help us with measurements. Let's see. Alright, so here's what we're going to do for some of our problems. The first part is we're going to find the scale dimension given the scale and the actual dimension. And we'll use proportions to do that. You can also do these in your head. You don't have to use a proportion, but since we just learned about proportions, I thought it would be some good practice to do it that way, and it helps us ensure that we have the correct answer. So if I write 1 with those quotation marks after it, that really is a way of saying 1 inch. So make sure you notice that. So in number 1, we're given the scale. The scale is that 1 inch is going to be equal to 2 feet. And we're also given the actual dimension, and the actual dimension is 18 feet. So each time we're going to write the scale dimension ratio. The ratio will be the scale dimension, or the measurement on the drawing, over the actual. Okay, so in number 1 through 5, they're giving us the actual dimension, so that will go on the bottom of your ratio. So the first ratio you use is the scale. We just write 1 over 2, you can ignore the units for now, is equal to what we're looking for. We're looking for what is the scale dimension. We don't know. So you can put an X or a Y or an S or whatever, and it'll be over the actual dimension, which is 18. And I wrote this already, but I'm just showing how I got that. And then we would use cross products to simplify this, but you can also just use proportional reasoning and saying, well, I know that 1/2 is the same as what over 18? You might know this. And if you do, then you'll be quicker than this. If we're going to use cross products, you would take 1 times 18 equals 2 times x. Of course, 1 times 18 is just 18, so we have a very simple problem to solve where we just have to divide both sides by 2 to get our answer of 9. So 1 over 2 is equal to 9 over 18, and that checks, that works, so 9 inches is our answer. Then we'll put our units back. The scale dimension would be in inches. The actual dimension was in feet. So 2, 3, 4, 5 are all done the same way. You're going to be using the scale that they give us and the actual dimension, and you are supposed to find the scale dimension. Let's do number 3 because there's a fraction in the scale. It says 1/2 inch over 2 feet. That's the ratio, and we want to find the scale dimension, and we're given the actual dimension. So you could change 1/2 to 0.5, but let's look what happens when we multiply it. To do cross products, what is 1/2 times 10? That's another way of saying what is 1/2 of 10, or what's half of 10? I bet you know the answer. Half of 10 is 5, and that'll be equal to 2 times x. So 1/2 of 10 is just 5. And then you divide both sides by 2, and you would get 5/2, and you can do that on your calculator if you want to write it. You can write it as 5/2 inches, or you can change that to a decimal. It'll be 2.5 inches. All right. So in the next section, all of these are going to use a scale of 1 to 2. So that will be one of our ratios, 1 to 2, for each one of these, 1 to 2. And we are going to figure out the actual dimension given the scale. So this time they're going to give us the scale dimension, the top number, and we'll be looking for the bottom number. So remember, it's scale dimension over actual dimension each time. Okay, so this one is already done. You can look through it. Number 7 is partially done. We're looking for, if the scale is 1 to 2, what will be the actual dimension if the scale is 6? So we start out by writing our proportion, 1 to 2. 1 over 2 is our first ratio. Our second ratio is 6 over some number. So then we solve with cross products. 1 times x equals 2 times 6, and then you finish that problem. Again, you might be able to do some of these problems in your head without setting up the proportions, and if you can, that's just fine. 11 through 15 is exactly the same as 6 through 10, except instead of a scale of 1 to 2, it's a scale of 1 to 4. So you're going to figure out the actual dimensions given each scale, so given the scale of 1 to 4. And so in 11, the scale dimension is 6. So we had 1 over 4 as our first ratio. 6 over some other number is going to be our second ratio. In 12, we still would use 1 over 4 as our first ratio because that's our given scale. And this time they tell us that 9 is our scale dimension, and they're again looking for the actual dimension. So you would solve this proportion, and you would do that for the rest of them as well. Okay, now we're going to talk about, instead of scale, scale factor. It's just another name for a scale ratio that's written in simplest form. So when we are looking at scale factor, like on a map, we usually say 1 inch equals so many miles. We don't say 4 inches equals so many miles. We want it in as simple a form as we can get it, and that's our scale factor. So the way we do this is we just write the scale as a fraction. So again, it'll be the scale dimension over the actual dimension, and then we simplify that ratio. Scale dimension over actual dimension. Let's look at a couple examples. The first one is done, so you can look back at that one as you need to. Let's look at number 17. So we start out with 3 inches over 12 feet. That's our scale. And we want to simplify this. We just want to simplify it. So we are going to try to find a common factor that we could divide each of these by to write this as, instead of 3, as 1. So if we divide both of them by 3, 3 divided by 3 is 1 inch. That's good. And 12 divided by 3 would be 4. And what is this? This is feet. So we keep our units the same. So this would simplify to 1 inch to 4 feet. And that's now our scale factor. see if there's any that look a little trickier. Not really. You're just going to write them in simplest form. On the last part, you're going to just pick 3 of these problems to solve. You don't need to solve them all. And remember that we'll use the scale dimension over the actual dimension if you need to write the scale factor. So in number 21, a drawing of a man, that's your scale dimension. Is 4 inches high. The actual man is 64 inches high. That's the actual. So you just write this as a fraction and then simplify it. That's all you have to do. Let's look at 22. A map shows the distance between 2 parks is 5 inches. That's the scale dimension. And Brianna knows the actual distance is 20. So this would be the scale dimension. What is the unit scale factor of the map? So again, you just need to write it like a fraction and then simplify it so that we can get it in the simplest form we can. So divide each of them by a common factor, which looks like 5, and keep the units the same. How about 24? The scale on the map says 1 inch equals 5 miles. That's the scale. Jamie measured the distance between 2 cities and found it was 6 inches on the map. What is the actual distance between the cities? So we could write this like a ratio, 1 inch over 5 miles, and we could say that's equal to the scale dimension over the actual dimension. So the scale dimension on the map was 6 inches, and we're looking for the actual. So you could use this proportion to find the actual distance between the cities. So I'll let you finish those up, and if you have any questions, please let me know.